Hi students, and today I'm going to talk about thermodynamics. And in this lesson, I'm going to discuss about heat capacity. Actually, why heat capacity we need to talk about? So heat capacity differ from substance to substance. So here we use heat capacity to to measure measure the quantity quantity of heat, Q, quantity of heat transferred to the system, or the measure of the quantity of heat loss from the system. So the heat capacity is the term, or heat capacity is the method of measuring the quantity of heat transferred to the system or lost from the system. Let us see how to measure the quantity of heat transferred to the system or lost from the system. Assume that there is one system in which a chemical substance is present, and let us consider the substance, the initial temperature is T1. When the small amount of small amount of external heat is transferred into the system, there is temperature change to T2. And the small amount of Q is added to the system temperature change. There would be temperature change from initial to final. When there is a change in the temperature, so the temperature difference will be delta T is equal to T2 minus T1. Temperature difference. So temperature difference is T2 minus T1 is delta T, we say. That means when the small amount of heat, the quantity of heat is transferred into the system, there will be rise in temperature. So temperature increases of the system, whether the system is gaseous system or liquid system or solid system. When the small amount of heat is applied to the system, automatically temperature changes from initial to final. So there would be rise in temperature takes place of the system. So where the rise in temperature of the system is directly proportional to the quantity of heat supplied to the system. Then we can formulate Q is directly proportional to change in temperature. Change in temperature or rise in the temperature, we say. More is the Q, more will be the increasing of temperature of the system, where delta T is equal to T2 minus T1, temperature difference from final to initial. And if you take out the proportional T constant, Q is equal to coefficient into delta T, where the constant coefficient indicate C, which is called heat capacity, which is multiplied with temperature. then Q is equal to coefficient into delta T. So C is indication of heat capacity. Heat capacity of a substance. So the heat capacity C depends upon this C depends upon quantity of the substance it depends upon quantity of the substance or composition of the substance, and also nature of the substance. It differs from substance to substance. Nature of substance, that means absorption of heat by the substance, different substance will be different. So one substance absorb more heat and increase the temperature. One substance absorb less heat for increasing of the temperature. So there is a relationship between the quantity of the substance and heat capacity. For example, more is the heat capacity of the substance, less in increasing of the temperature, we say. That means we must heat the substance for a long time for increasing of the temperature. So when there is large in heat capacity, large in C, so we must need Q must be large for raising or for rising temperature. So 1 degree Celsius. The heat capacity is more, then we need to heat the substance for a long time for increasing of the temperature, we say. When heat capacity is less, and we need small amount of heat for increasing of 1 degree Celsius temperature. That means the measure of heat transferred to the system or lost by the system can be expressed in terms of molar heat capacity. We can take another term is molar heat capacity. Molar heat capacity. So what is molar heat capacity? The molar heat capacity is indicated with Cm, which is divided by heat capacity upon 1 mole of substance. 1 mole of substance. That means for increasing of the temperature, for raising of 1 degree Celsius temperature, 1 degree Celsius temperature, for 1 mole of substance, 1 mole of any substance. So for 1 mole of substance, the amount of heat transferred is equal to what we call means molar heat capacity, we say. Molar heat capacity. So we can write Cm is molar heat capacity. C is the heat capacity of the substance divided by 1 mole of any substance, 1 mole of the substance. That means, so for rising temperature 1 degree Celsius, for 1 mole of the substance, the Q is required is said to be what we call means Cm, molar heat capacity, we say, with respect to 1 mole. is called molar heat capacity. So, but to precise or to measure more specific, we use another terminology that is called specific heat capacity. The specific heat capacity we use, and which is equal to Q is equal to heat capacity into mass of the substance multiplied with delta T is the temperature. So what is a specific heat capacity of the substance? So for raising of 1 degree Celsius temperature, 1 degree Celsius temperature or 1 Kelvin temperature, Q is required. Q is required. Heat is required for increasing of 1 degree Celsius temperature. For 1 gram of any substance, 1 gram of amount of substance. So for the amount 1 gram of any substance, Q required, the quantity of heat required for raising 1 degree of Celsius temperature is said to be what we call means specific heat capacity, we say. That means the increasing of the temperature depends upon the mass of the substance and nature of the substance. For rising of 1 degree Celsius temperature, increasing of 1 degree Celsius temperature, the amount of Q required per 1 gram is said to be specific heat capacity of the substance, we say. The specific heat capacity for water will be how much? Nearly 4.2 joules. 4.2 joules per Kelvin per gram. So specific heat capacity for what is more, and the specific heat capacity measured, since heat is measured in terms of joules. So joules per Kelvin per gram we can measure. So this is what we say the specific heat capacity. The formula is Q is equal to C into M into delta T. This is the formula for specific heat capacity. The specific heat capacity differ from substance to substance. So for water, specific heat capacity is 4.2 joules per Kelvin per gram. So we can write the